Hi, we are the mountain climbers, and we're going to be doing our project, which is on directional derivatives, gradients, and bus routes.
So the first concept we're going to be covering today is partial derivatives. So partial derivatives, which we can notate using del, or which kind of looks like a backwards six, are what we can use to measure change with respect to one variable in the context of multivariable functions. So an example where this could be applicable is, say, our bus is traveling up a mountain, and we only want to find the rate of change of its vertical motion. We could take this function, which has both variables x and y, that maps its movement, and we can find the partial derivative with respect to y, which would be notated by f sub y of xy, or the partial derivative with respect to y. So the mathematical formula we can use for this is f sub y of ab will be equal to the derivative of h at b, where h of y is equivalent to f of ay.
So the next topic we're going to be covering is the gradient vector, also known as the direction of greatest change, which you can also find at a specific point by plugging in like a specific point. So for the 2D, it's just notated with the upside down triangle f. And the x component is the partial derivative of the function f with respect to x, and the y component is the partial derivative of the function f with respect to y. And then in the 3D, same deal. The x and y components are the same, and then there's the third component, the z component, which is the partial derivative of the function f with respect to z.
Directional derivatives, the rate of change of a multivariable function at a specific point and in a given direction. The expression is d sub u f, which is equal to the gradient of f dot u, where u is a unit vector.
The first type of problem we will face is finding the gradient with fxy and point AB. So imagine a bus travels along a terrain represented by the function fxy, and you are at a bus stop that can be represented with point AB. How do you figure out the direction of the greatest rate of change at that certain point?
To solve this problem, you're going to start with the definition of the gradient, which is that the gradient of function f is equal to the partial derivative with respect to x, and then the partial derivative with respect to y. And your first step is going to be to differentiate f of xy with respect to x, which will give you your first partial derivative. And then your second will differentiate with respect to x, or with respect to y. And then once you have both of your partial derivatives, you're gonna substitute point A, comma B into both of the derivatives that you found. And the resulting vector, which is the gradient of f at point A comma B, points in the direction of the greatest increase of f, and it tells the magnitude, which is how fast f increases at that direction.
The second type of question you might encounter is to find the unit vector. So you may imagine a bus leaving your stop at point AB and starts driving towards another point at CD. How do we figure out the exact direction that the bus is moving without worrying about how far it goes?
And we're going to do this by finding the unit vector. First, we'll find the vector between the 2 points, which shows the change in position. And that's going to be equal to C minus A, comma, D minus B. Then we're going to find the magnitude of that vector to see how long it is. And the magnitude of the vector is equal to C minus A squared minus, or plus D minus B squared. And you're going to take the square root of the sum of these squares. And then finally, we're going to divide each component by the magnitude to get the unit vector. And to solve that, it would be the unit vector divided by the magnitude of the vector, which is equal to C minus A divided by the magnitude of V, comma, D minus B divided by the magnitude of V.
The third type of question you may be asked is to find the directional derivative of the given function. The question asked is to find the directional derivative of the function f of xy at a point in the direction of a given vector. To find the directional derivative, find the dot product of the unit vector and gradient using the formula. The directional derivative is equal to the dot product of the gradient of f of xy times the dot product of the unit vector.
And so that's going to be the directional derivative of f at point x comma y is equal to the partial derivative with respect to x multiplied by u1 plus the partial derivative with respect to y multiplied by u2. And once you find that, you're going to substitute in point AB to find the directional derivative at that point, which will tell you how fast f changes in the direction of u. Thank you for watching.